Let's cover notation first. So let's say you have a function. You can call it f of x, or y, or g of x, or whatever you want. If you take the derivative of that function, you would call it f prime of x.
And what does that do? There goes my backpack.
F prime of x. So the little mark there is called a prime, okay, and that is how you take the derivative. Now, what if your function was called y? You would call the derivative y prime. Okay, what if it was h of x? You'd call it h prime. Now, there's one other kind of weird notation that we're going to cover, but it's dy dx. That is the same as y prime. So if you see y prime, f prime, dy dx, those are all just different notations for the same thing. Okay? Now, you also have what's called a double derivative, or a second derivative. And a second derivative, instead of only putting one prime, how many might you put? Two. So it'd be f prime prime of x.
What?
Or y prime prime.
But what does the prime do?
It just is the symbol for derivative. And you're going to figure out how to take them in just a second. Now, this one gets a little bit weird. So you have d squared y dx squared. Okay, and what that stands for is the derivative twice. So d dx stands for derivative, d squared dx squared stands for the derivative twice. Okay? But for right now, we're not going to get wrapped up in what it stands for. We're just going to talk about how to do it today. Okay? So I'm going to give you 3 rules up front, then we're going to practice them. Your first rule is going to be the power rule. If you take the derivative of x to the n, and then also you're seeing that d dx there, that means derivative. Here's what you're going to do. You're going to take whatever your exponent is, n, you're going to multiply it down to the front, and then you're going to reduce the exponent by 1. So if your exponent was an n, now it's an n minus 1. Sounds more complicated than it is. I'll show you how to do it in a second. Rule number 2, the constant rule. Whenever you take the derivative, that's d dx of a constant k, you get 0. The derivative of a constant is always 0. And then your third and final rule is the sum or difference rule. If you take the derivative d dx of f of x plus g of x, oh, I ran out of room. That's the same as f prime of x plus or minus g prime of x. Can you even read that, hopefully? Okay, that says f prime of x plus or minus g prime of x. Okay, ready to do some examples? Plus or minus g prime of x. So they just both have little primes on them. So instead of f plus g, it's f prime plus or minus g prime. Okay, good? Alright, so first example. Okay, this is really easy at first. So you're going to have the derivative of, we'll say, 10x to the fourth. Okay, so the first thing that you're going to do, this is a power, so we're going to use the power rule. So you're going to take whatever the exponent n is, you're going to multiply it down to the front. So if I have a 4, I'm going to multiply that down on the 10. What do I have now? 40. And then my n, whatever it used to be, I'm going to minus 1. So if it used to be an x to the 4, minus 1 from that, now it's an x to the third. Easy, right? Okay, number 2. Let's say you have the derivative d dx of 6x cubed. Okay, same exact thing. You're going to take your exponent, you're going to multiply it down to the front. 3 times 6 is what? 18, and then your power goes down by 1. It used to be cubed, now it's squared. Good? Okay, next one, rule number 3, or example number 3. d dx, remember that means derivative, of 5. Is that a power?
No.
That's a constant. Look at your constant rule.
0.
Derivative of a constant is always 0. Now, let's say that you didn't know the rule and you want to know how to do it so you don't have to memorize the rule. This is what you would do. Or I could take my 5 and give it an x to the 0 behind it and do power rule on it. So think about it. X to the 0 is really just a 1. So if I need an x there, I make it x to the 0. And then what happens when I times this power down? 0 times 5 is 0. And then no matter what x is to, if I'm timesing it by a 0, it's going to come out to be a 0 at the end. So if you prefer to just memorize the rule, that's what I would do. But if you want to work it out every time, pop an x to the 0 on the back, do power rule on it, you'll still get the same answer. Okay, last example of that type. So, d dx of 3x to the fourth, 7x squared plus 2x plus 6.
That's a big jump.
It is, but all that this is illustrating is the sum or difference rule. So notice, the sum or difference rule says if I take the derivative of things that are added or subtracted, I just add or subtract the derivatives. So you're going to go one term at a time, doing the exact same rules every single time. So for this one, what rule do I use? Power. So 4 times 3 is 12. What's my new power? X cubed. Then I move to the next term. Take the derivative of this guy on his own. 2 times 7 is 14. X is to the what now? 1. Then I move over to my next term. I'll take his derivative on his own now. If it's a 2x, that's 2x to the what? To the 1. So put a little 1 on there. 1 times 2 is 2. And x is now to the what? 0. Okay, last one is a 6. That's a constant. What's the derivative of a constant? 0. Now, obviously, some of those terms look more complicated than they need to be. So for my final answer for that, I'm going to put 12x cubed, 14x plus 2. Okay, since it's day 1, I kind of wrote out each term. But x to the 0, you would just not put it. Plus 0, you would just not put that. Good?
Is that it?
Yep. Okay. Now, I mean, it'll get a little more algebra-y, but for now, may I turn the page? Are we good? Okay. All right, next one. Okay, we are going to take the derivative of y equals 5x cubed, 8x squared, 7x plus 4. Okay, I'll give you a second. Every single one of those is either the power, constant, or sum and difference rule. We're going to call the derivative what?
D over dx.
Okay, you can call it dy dx, or what else could you call it?
Y.
Y prime. Good. A. Okay, times the 3 down. What's your first term?
15x
15, now x is only squared. Next term, times the 2 down. 2 times 8 is 16, x is to the 1. You can write it, not write it, up to you. Next term, 7x is to the 1. Multiply 1 times 7, you get a 7x to the 0. Nobody cares, don't write it. Okay, then what about plus 4? Constant derivative is 0. Okay, now I want you to take the second derivative. So, d squared y dx squared, or y double prime. All that means is you're going to take the derivative one more time. So, term by term, same rules apply. 15x squared, what's my derivative?
30.
30x. And x is technically to the 1, you just don't have to put it. Okay, 16x, what's my derivative? 16 only. And what about plus 7?
0.
Constant derivative is 0. Very good. Make sense? Now, what if I asked you use your power of deductive reasoning skills? What do you think that means?
Third power.
The third derivative, then you'd take the derivative one more time. So what's the derivative of 30x?
30.
30 only. What about the plus 16?
Constant.
Goes away. Very good. Make sense? Okay, cool. All right, next one we're going to look at. Number 6. Y equals 6x to the 4th, 8x cubed minus 12 divided by 2x.
Ew.
No, not ew. Okay, so the only rules that you learned are power, constant, sum, and difference. That means you have to rewrite that as a power. This is a quotient, it's divided, so we're going to fix it just by simplifying. Regular algebra skills apply, so I'm going to put RW, that stands for rewrite, and before I take the derivative, I'm going to have to convert that into individual power terms. So I'm going to have 6x to the 4th over 2x. Then I'm going to have 8x cubed over 2x. Then 12 divided by 2x. And what you're going to do is simplify each of those guys to where each of them is a single term that's not a fraction anymore. Okay, which you should know how to do. First term, 6 divided by 2 in the front, what do we get? 3. How many x's are left over? I had 4 on top. I have 1 on bottom. What do I do with the exponents when I divide? Subtract, so x to the 3. Okay, next term, I have 8 divided by 2 in the front. What's my constant? 4. How many x's left over?
2.
Squared, very good. Then for my last one, 12 divided by 2 is 6. There are no x's to combine. How do I write it as a power if it's on the bottom? Negative. X to the minus 1. Okay? Now that it's written as a power, you can take that derivative. So y prime equals, or you could call it dy dx, that's the same thing. Term by term, what's my first term?
9x squared.
9x squared. 3 times 3 is 9. Multiply that down, then take away 1. Next term, 2 times 4 is 8. X is now to the 1. You can write it or not, up to you. Last one, multiply the negative 1 by the negative 6. What do you get?
6.
X to the what? 0? Negative 2. Okay, because remember, if I minus 1 more from negative 1, I get minus 2. Good?
Wait, how do you get the negative 2?
Because it's minus 1 from minus 1. Yeah? Okay, now, before we go on, I want you to rewrite that as a fraction. So that would be or 9x squared plus 8x plus 6 over x squared. Okay, so you could write it in either form, but typically on the AP test they're not going to leave negative exponents, so you should kind of get yourself used to that as well. Now, y prime stands for the equation for the derivative. You can also have a derivative at a point. So let's say that I asked you to find y prime at 2. What do you guess that means given what you know about functions? You're going to take y prime and do what? Plug in 2. Exactly right. So I'd have 9 times 2 squared plus 8 times 2 plus 6 over 2 squared. And all that you would do is take the number they're asking you to plug in, put it in the spot where the x is. So 2 squared here is 4. What's 9 times 4? 36. 8 times 2 is 16. 6 divided by what here? 4. Can that reduce? 3 over 2. Good. Okay, now put those first terms together. What is 36 plus 16? 52. O plus 3 over 2. And now from here, you're going to have to get a common denominator. So remember, the way that you do that is you're just going to multiply by 2 on top and on bottom. So 2 times 52, how much is that now? 104 halves plus 3 halves. How many do we get?
53 and a half.
Or 53 and a half is also fine. Sure. Whatever you like better. Okay, so if it's regular y prime, you're just taking the derivative. If it's y prime at a number, you're plugging that number in. Good? Okay, all right. Can I turn it? Okay. All right, number 7. Okay, you're going to have y equals 1/2 x, oops, hold on. 1 over 2x to the 4th plus 6 over x to the 3 plus x3 minus 5x plus 4. So that is supposed to be 1 over 2x to the 4th all on the bottom.
Oh. You tricked us with this easy stuff and now you're bringing us.
No, but we just have to build to it, you know. Okay, so the first thing I want you to do is an RW, a rewrite. Okay, so I want you to rewrite each of those terms to be a power only. So for example, I cannot leave x4 and x3 in the denominators. Would I rewrite the first term as 2x to the minus 4? No. What would I do? 1/2 x to the minus 4. What's up? Huh?
Oh, I'm sorry. Can
Huh?
you talk real quick?
Oh, for student, yeah, go.
Alright, everybody, hi. Basically, we're doing senior class t-shirt designs. We're just asking y'all about wanting design a t-shirt because
Speak clearly.
sorry. Alright, so there's gonna be a senior class t-shirt designs. Basically, use submit a design and then it's due by Friday. It just
Do you have a paper for me to put up here for you?
I'll
Okay.
give them to people.
Oh, okay.
Yeah, you can make them all and then we vote for them.
Cool.
Yes, you will. You can. There will be. There could possibly be a $50 gift card, and then you also get your shirt with it.
Ooh, cool.
Would anybody want to do it?
Yeah.
You ain't gonna do it, bro.
It's a free $50, bro. It's a free shirt.
I mean, you like reason. Don't put drugs on it or anything, huh?
Take that paper away, my brain goes. She's got a big brain in that.
Okay, so your first term, remember the x can move up, the number can't. You need to leave it as a 1/2. Okay, the next term would be what? Okay, then x to the 3, 5x plus 4. The last terms don't change. Okay, take the derivative. We're going to call it y prime. And then I want you to rewrite y prime without any fractions. Or with fractions, no negative exponents. So step 1, multiply the negative 4 down. Half of negative 4 is? Take away 1 from negative 4. What do you get? Negative 5. Very good. Next one, I have negative 3 times 6. What's that? So I'll make it a minus 18 in the front. X is now to the what? Good. Plus, next term is an x cubed. Derivative is? 3 in the front, x to that 2. Then negative 5x, what is it?
3x squared.
Yeah, 3x squared. Then the next term?
5.
Minus 5. What about the plus 4? 0. Okay, rewrite it without any negative exponents. So we'd have negative 2 over x5 minus 18 over x4 plus 3x squared and then minus 5. Okay, so on the AP test, it would be unlikely that this would be an answer choice, but if it's free response, you could leave it like that and it would be fine. But if you're having to match an answer, you should know that they're not going to leave negative exponents. Okay, good? Okay. Alright, next one. Let's do some radical roots. Okay, 4. Huh?
How many of these examples are there?
I think there are 11. No, there are 12. You're on 8. Okay, next one. 3, x5.
The 7 in the box.
It actually doesn't matter. Put it outside. But it doesn't matter. If you put it inside, it makes no difference. Okay, so remember that fractions, you will have to rewrite those with negative exponents to convert them into power rule. Okay, for radicals, you will have to use a fractional exponent to turn them into a power. So you should remember this from pre-cal. If this is a root and a power, what would the exponent be on it? Well, so the 4 is like a coefficient. So if it's a square root, that means the index is a 2. 7 over 2. Very good. So the top number is going to be the power, and then the bottom number is the index of the root. Okay, so my power is 7th power, and then it's square root, so a root of 2. Okay, next term. This is a rewrite. I'm not taking the derivative yet. Okay, what would 3 square root x fifth be? 3x to the what? 5 over 2 plus. Last one would be 2. Regular square root is a half. Now, that was a rewrite, RW. We did not actually take the derivative yet. Okay, here we go. Once you take the derivative, y prime equals. Okay, I'm going to do 4 times 7 halves. I'm going to write it out first. I'll do it in a second. And then for my power, if it used to be to the 7 halves, I'm going to have to minus 2 halves. Now, you may not have to write this step. That's fine with me. Okay, but when I multiply, here's what you're going to do. 4 times 7 on the top, what do we get? 28, then divide by 2. So it's a 14 for your coefficient. Then in the exponent, if I need to minus 1, I'm going to minus 2 out of 2. So what is 7 halves? Take away 2 halves. X to the 5 halves. Next term.
Can you combine?
You can only combine like terms if they're the same type. So the 5 halves is about to change to not be a 5 halves anymore. You know what I mean?
Because that's 5 pounds.
Yeah, but we're about to take the derivative, right? Okay, so next one. I'm going to have 5 halves times 3. I'll do that in a second. And then my power is going to be x to the 5 halves minus 2 halves. So let's go one thing at a time. for the fraction, you times the tops. What's 3 times 5? 15 over 2. And then in my exponent, I had 5 halves. I'm taking away 2 halves.
You get
3 halves. Okay, last one. 1/2 times 2 is going to be my first number. And then x is going to be to the 1/2 minus 2 halves.
negative.
Negative what? 1/2 for the power. Now, my leading term, though, 2 times 1/2, that's just a 1. And then x is to the minus 1/2. Okay, now we're going to rewrite that without any negative exponents and no fraction exponent. So they have to go back now to radical form where you see the roots and stuff. So for my first one, I would have 14x to the 5th square rooted. My next one, I would have 15 over 2 in the front. X is cubed and square rooted. And then for my last term, if it's a minus 1/2, where does that belong? Under, yeah, so I'll put 1 over. And then root x. Good. Under the numerator or in the denominator. All good ways to say it. Good. Look, you're already on example 8. Okay?
You know, I was starting to thrive in that, but now it's like...
Now it hit me.
You were starting to thrive. You're going to still thrive.
I feel like a genius with limits now, like so I don't take carnage.
Okay, next one. Are you ready? No? It's okay.
I had to mess
Now you are?
just a little bit.
Everyone? Okay. Okay, I'm going to give you a minute to try this one before I do it for you. Okay, so number 9, y equals 6 cubic root x to the 4th plus 9 cubic root x to the 5th plus 2 cubic root x. Okay, I want you to try it on your own. You're going to convert them first. Remember, power stays on top, root stays on bottom.
How many is it?
There are 12. So you're on 9. So you're converting it first to make it all fraction exponents. Okay, you can label it an RW if you need to for a rewrite. What's my first exponent supposed to be?
6 over 3.
6 times x to the 4/3. Next one would be what? Okay, 5/3. And then 2x to the, what if no powers here? It's a power of 1, so it'd be a 1/3. Okay, label your y prime. I'll give you a minute to think about each term. And when you minus 1, you're not going to make it 2 out of 2. What are you going to minus? 3 out of 3, so that it's still a unit fraction. So I'd have... Okay, I wrote the first term out for you, but you'd have 6 times 4/3. And then I'd do 4/3 minus 3/3. If you can do this in your head, do it. Awesome. Okay, it doesn't bother me at all. So for my fraction, remember, I do 6 times 4, 24. Now divide it by 3. 8 is the number. And then what is 4/3 take away 3/3? 1/3. Okay, you do the next two terms.
What are you counting? You're a retard.
Wait, is that equals to the factor or negative?
Are you talking about here? It's an equals.
You keep touching me, bro. That shit annoying.
Yeah.
Like for like the last one.
So you put it on the bottom. X would be squared and then cubic rooted.
With the x on the bottom. And it'll
Yep.
be, okay.
Okay, so your second term, what's 9 times 5 on the top? 45 divided by 3 is? Okay, then 5/3 minus 3/3 is?
15 2/3.
Okay, then last one, we're doing 2 times a third.
2 over 3.
And then 1/3 minus 3/3. So that is going to be a 2/3 as my power, or as my coefficient. So 2 times 1 is a 2 on top over 3. And then 1/3 minus 3/3 is negative 2/3. Okay, now rewrite it. No fractions and no negatives in our exponents. So what would my first 1/3 power be? 8 cubic root x, very good. Next term, 15 stays in the front. Cubic root x what? Squared. And then for my last one, 2 over 3, and my x is going to meet my 3 on the bottom. So when I write my x to the 2/3, it's going to be down here in this spot. So it'll be x to the 2 and then cubic rooted. Good? Okay, sweet. Number 10. Almost there. Y equals 3x cubed 5x squared plus x plus 2 over root x. Okay, now think about, we did not cover a quotient rule. So if it's written as a fraction, you're going to have to make it not a fraction anymore. You're going to use the same strategy we used when it was a 2x on the bottom. You're going to have to split it up where everybody gets their own square root x on the bottom, and then you'll simplify each term one at a time. So, for example, I'll have RW rewrite 3x cubed over, what is root x the same as? X to the half, good. Okay, then I'll have plus 5x squared over x to the half plus regular x over x to the half, and then plus 2 by itself over x to the half. And then you'll have to reduce each one of those to make it a single power rather than leaving it as a fraction with x's on top and on bottom. Now, what is the goal with the exponents? What do we want to do with them? Subtract. I need to be able to subtract these two. So if I need to do 3 minus a half, then I'm going to convert 3 to be in halves. So multiply by 2 over 2. 3 over 2, 3 times 2 is 6 halves. So what is 6 halves minus 1 half? That's 3x to the 5 halves plus. Next term, I have a 4. I don't like it as a 4. I'm going to times it by 2 over 2. Now it's 4 halves. And if I have 4 halves on top, but I'm canceling one of the halves with the bottom, how many are left over? Close? 3 halves for my second term. Now, my next x is to the 1. That's like a 2 halves. So if I have 2 halves on top, canceling 1 half off the bottom, what's left over? X to the 1 half. And then for my last term, x to the half is on the bottom. I'm going to bring it up, and my 1 half will now be negative 1 half. Very good. Now, keep in mind, have you taken the derivative yet? No. All you did was rewrite it so that now we can take the derivative. Okay, so this is exactly the same as this. It's just written differently. Okay, so now that we're taking the derivative, we're going to label it y prime. Okay, first term, 3 times 5 halves. I'm not going to write that middle step this time. But what would 3 times 5 halves be? 15 halves, because I do 3 times 5, get 15, can't divide by 2. Then I'm going to minus 2 halves. What's 5 halves minus 2 halves? 3 halves, or 3 over 2. Plus 3 halves times 5 again is now a 15 halves. But if I'm minusing 1, that's the same as 2 out of 2. What's 3 halves minus 2 halves? X to the 1 half left over. Okay, next one. X is to the 1 half. My 1 half moves down to the front. And now I need to minus 2 halves from 1 half. X to the negative 1 half. Okay, then for your last one, you have minus a half multiplied by 2. What's that? Negative 1. And then if I minus 2 halves from negative 1 half, what do I get? Negative 3 halves. Okay, then we're going to rewrite it. Okay, my first one is 15 over 2. But notice that my x is going to be on top with the 15. And it'll be 3rd power square rooted.
This is not full. This is too much.
15 over 2.
When, in real life, how do we use derivatives?
Usually you'd have a program to do it for you.
Right.
But. Okay, next. Okay, when I get to the third one, when the negative powers start, where do those go? On the bottom. So look, when I write this guy, I'm going to put 1 over 2, and then my root x is going to be like, oh, we're on the bottom, we're friends. Come on, slime. Let's go to the bottom. And then 3 root. Yay, you're done, see?
Two, I'm like, what is this? This is like alien.
Okay, do we need to not finish the other rules and just, okay. Alright, I'm going to give you like 3 to do off your homework. So you can try it. Okay, you're going to do
We're about to be.
1, 3, 5. 1, 3, 5. Okay, and then y'all remind me tomorrow. We didn't get to the special rules. Well, maybe you don't really have time.
So we would find the derivative and then